Okay. Chapter 3 mainly consider about the conversions. Then after conversions, we will move to the logic gates. Okay. So first, we are considering our computers as digital devices. Why we call it as digital? It consists of binary numbers. Binary, that means digital, 1, 0. Those are binary. So binary patterns are available. Therefore, we call it as a digital. So digital devices represent everything as a number in our computer. So entire machine work as a binary data flow, that like a number pattern. So numbers, characters, symbols, images, audio, video, everything will move through the computer cables as digital signal. But my voice is going to the machine as audio signal. It converts inside as a digital signal. Okay. So whatever the natural data will gather as analog signal, then inside the machine, it will detect as a digital signal. So for example, if I want to call Cortana and search something, so my voice is going like analog signal, but Cortana is searching everything, the commands what I give in digital format. Okay, so analog digital conversion is there inside as well. All modern digital devices use binary numbers base 2. So digital devices are base, that means binary numbers base 2. So that means 1 zeros. Instead of decimals, decimal means base 10. The smallest digital device is the bit. So when we consider about the binary number, the digi, uh, smallest unit we call as bit. Okay, bit means 1 or 0. A bit is a binary digit that is a number that either 0 or 1. Computers ultimately represent and process everything as bits groups of bytes groups of bits. That means bits as a bits groups of bits. So bits mean 1 0. The group of bits we call as 1 byte. That means 8 bits together we call as 1 byte. BYTE. Byte means 8 bits. So group of 8 bits we call as 1 byte. Represent larger things. So numbers, letters, words, names, pictures, sounds, instructions, everything represented in binary. The interpretation of group of bits depend on their context. So now you can see the screen. So this screen, these letters, numbers, everything represent inside the computer as a digital format, ones and zeros. Okay, is this clear? Okay. In this slide, there are some O-level theory point as well. Therefore, you better copy only the highlighted points. So if the rest of the things no need to write. So digital device represent everything as by numbers. Then numbers, characters, symbols, images, audio, video, and all media items, instructions are represented by binary numbers in digital devices. So binary numbers are based on base 2. Okay, you will write there binary numbers are based on base 2. Based on 2. That one should be there. Then a bit is a binary digit that the number that is either 0 or 1. Only those highlighted points are necessary. If you want, you may write the rest later. Okay, decimal numbers. So decimal numbers mean numbers what we are using normal day-to-day work in our calculations. Okay, so decimal numbers are based on 10. So decimal numbers are starting from 0 and ending at 9. There can only be number 10. So 10 mean 1 0. So starting from 0, ending at 9, whatever the decimal number made out of with these 0 to 9 digits. So it is called the decimal number system because 10 digits available on this number. It is based on 10. The decimal point is used to separate functional part of a computer, sorry, fractional part of a number. Decimal point, dashama sthane. Okay? Decimal point is used to separate fractional part of a number. Fractional part can bhaga sankhya. Okay, so that means if you have 5.5, that means 5.5 0.5 can half mean the fraction part. හරි 5.5 කියන එකේ 0.5 කියන්නේ භාගය. භාගය කියන්නේ fraction part එක. ඒතර ඒ භාගය අපි represent කරන්න පුළුවන් decimal point එක දශම ටික තියලා point මොනවාද 5 කියලා. කියන්නේ if you consider about 5.5. Okay, this half mean it's not displaying for you, ne? Okay. Just think 5. Okay, 5.5 is there. So half mean this is a fraction part. So this fraction part we can represent as 5 decimal point 5. Okay, so here the decimal point is used to separate the fraction part of a number. So using decimal point, we can separate the fraction part. This is a decimal point. Okay, so plus sign is used to show the positive and values and negative values. Negative value, negative sign is used to show the negative value. So here this point we call as decimal point. You better copy the slide. Okay, next one we are going to discuss about the integer. Integers mean number set, natural numbers. It can be either plus positive numbers as well as negative. So plus 0, 1, 2, 3 and -1, -2, -3 are integers. But there cannot be decimal point. Neither decimal number nor fractions are integers. There can't be decimal number, decimal points, decimal numbers, decimal number mean dashama sankhya, I mean, okay? Decimal point, decimal parts or fraction. There cannot be decimal part or fractions. That means decimal number mean not the normal decimal. That here I mean the dashama sankhya, okay? Or bhaga sankhya. So now just look at this 0.75, 8.5, then half are not integers. Why? The 0.5. Then fractions are there. So decimal part and the fraction part is available. Therefore, we are not going to tell it is those as integers. But when we consider about the given examples, how about this one? There is a fraction decimal part. In this decimal number, there is a decimal part. So this is not an integer. And this one, -10, that is an integer. Here, this is not an integer because there is a fraction part. Bhaga sankhya or then here the decimal part is there. Therefore, it is not a integer. And here also decimal part, not an integer. Here fraction part, it is not an integer. Okay, is this clear? මොනවා හරි එක භාග සංඛ්‍යාවක් හරි දශම සංඛ්‍යාවක් හරි තියෙනවා නම් එයා integer එකක් නෙමෙයි. But the integer can be consist of plus or minus, never mind. හරි. Okay. Copy down this slide. හොඳට මතක තියාගන්න, you will need this one for Python programming as well. හරි, integers